This is the walkthrough video for PCTC 2021 round 2 question 3 ASCII table placemats. I think this question is actually really difficult. We're given some symbols and some numbers, and we need to follow the rules to create a placemat and display it on the screen. And the reason this is particularly difficult is because there might be gaps or spaces within our placemat between the central one and the outer placemat, like we see in the second example output. But first off, we'll do the easy bit, which is just inputting our 4 things. So we first need to input n, then n, m, then the first character, and finally the second character. And now, I'm going to tell you the approach I'm going to use to solve this. There are of course multiple approaches you can take, but what I'm going to do is I'm going to create a 2D list, which is n by n items long, and I'm going to go through every coordinate in our 2D list and check to see what character that coordinate should be. And if that coordinate should be, for example, character 1, I'm going to replace it with character 1. If it should be nothing, I'm just going to leave it as a space. And if it's neither of those two, it's going to be character 2. So let's start off by creating our 2D list. Let's call that mat. And we want spaces. How many spaces? We want as many spaces as the length of our list, which is just n by n. And this is going to be one row of our mat. But we want n rows of our mat. So let's do another list comprehension, like that. And so now we should have our 2D list, which is an n by n grid of spaces, or strings, where each string is a space. You can, of course, do this using nested for loops, or just for loops in general, but I think this is neater on one line. Okay, now for the logic bit. So we're going to go through every x and y coordinate in our grid, and then determine what character it should be. So let's include 2 nested for loops. So that's going to be for y in range n, because n is how many rows there are, and for x coordinates in range n, because again, n is how many columns there are, because it's an n by n grid. And we've got our coordinates x and y. Now, the first rule is the easier bit, is to check, are we at the border? Because if we are at a border coordinate point, then we just need to replace that with character 1. When are we at a border? We're at a border when either the x coordinate is equal to 0, like there, or the x coordinate is equal to n minus 1, so it's the final one in our grid, or if the y coordinate is equal to 0, like in this one, and if the y coordinate is equal to n minus 1, like at the end over here. And so we can just include that check. So if x is equal to 0, or x is equal to the final row, or if y is equal to 0, or if y is equal to the final column, then we want to replace the character at our coordinates yx with character 1, because this is a border, and then we can end it there. Now we need to write the logic that figures out whether the coordinate we are currently at should be a central mat character. And this is the one that's really difficult because it varies depending on what the 2 input numbers were. So how do we create the logic that does this? I'm going to draw how we're going to do that here. So in this case, we have a 7 by 7 grid. 7 by 7 grid. And the inner grid is a 3 by 3 grid. And we need to figure out where our spaces are. So in this case, of course, the spaces are all of those things in red. But we need to find a programmatic way to calculate that. So what we're going to do is we're going to notice that the very center of our overall mat is this point. And that point is, of course, also the center of our inner mat. And if it's the center of our inner mat, we can use that fact to figure out where the rest of our characters should go. For example, if that's the center, then we want to extend 1 out in each direction. We want to extend 1 upwards, 1 left, 1 down, and 1 right. And then we want to fill that entire yellow grid with our characters. Because in this case, it is a 3 by 3 inner mat. And so we can use that idea for any input number to figure out how many points in each of the 4 directions do I want to extend in from the middle cell. And if, for example, with this coordinate, well, that coordinate is too far left, it's too far away from the middle cell to be a valid coordinate for our second character, and therefore we can leave that as a space. And that's the logic we're going to use in this case. Now, how are we going to do that? We need to first figure out what the center of our grid is, and that is relatively easy, right? Because we're given the dimensions of our grid, which is n by n. And so the center of our grid, we're going to create a new variable, and that's just going to be n divided by 2. But because n is odd, and I believe it's always odd, yeah, it's always odd, we can't just divide that by 2, because then we get a decimal number. And so we can do integer division by 2, and that will give us the index of the center cell. For example, in this case, n is equal to 7, and then if we were to take that and do 7 integer division by 2, we get 3, and index 3, and so the coordinates 3, 3 is where our center cell is, because this cell is 0, 1, 2, 3, and same for the rows, just like that. And so our center cell is at 3, 3, which is just n integer division by 2. And we can do a similar thing for m, which, and just so remember, m is the dimension of our inner mat. And so we can take m and we can integer divide itself by 2 as well. And we can resay that as m, because we don't actually need the original value of m. That's pretty useless to us. The only useful fact is the integer division by 2. And what this gives us is it gives us how many steps in each of our 4 directions are we extending out to. So in this case, as you saw in the yellow, we're extending out by 1 unit in each of our 4 directions. And that's represented by our new calculated value of m. For example, if I integer divide 3 by 2, I get 1. And in this case, we can see that 1 is the amount of steps that we extend in each of our 4 directions. And the reason that works is because if we extend left 1, we're also going to extend right 1. And therefore, we've extended sideways in total by 2, 1 on the left and 1 on the right, as well as the original center point that we've marked on in green here. And so we've got those 2 from the side, plus the original center, which is 3. And so that's how we get our 3 by 3 dimension. And now that we have all of our new variables that we need to solve the inner placemat, let's actually write the code that creates this inner placemat. So we're going to say if x is within the correct range and y is in the correct range. So if we are in this yellow square, then we want to insert our character there. So if x is within a certain range, and what's that range going to be? So the lower end of that range is going to be our center minus m, and the upper bound of the range is going to be our center plus m. And we can do the exact same thing but for y. So center plus m is greater than or equal to y, which is greater than or equal to center minus m. So this is a long if statement, but it's essentially just the same range repeated twice, one for the x coordinate and one for the y coordinate. And because in this case, everything's a square, everything's symmetrical, it's literally the exact same code, just with x replaced with y. And so if this condition is met, then we know we are in the yellow center square, and therefore we can replace our current coordinates, which is yx, we can replace that with character 2. And so now at this point, we should have a final 2D list which contains all of the correct characters. And now we have to print it. Usually I'd say this is the hard bit of the problem, but in this case it's probably one of the easier bits of the problem. So let's just go through every row in mat, and we want to print out that row. And this is how you can print off a list in Python. Like, this is how you print off every item in a list in Python with a space between every item. But we don't want a space between every item, of course. But we just want all the items to be adjacent to each other. And so we have to add this extra parameter called sep, which stands for separator. And the separator in this case is just going to be an empty string. It's going to be nothing. And so we're just going to leave that as a blank string. And if we submit that code, we should hopefully get all 10 points. Nope. Where's the issue? Let's do some live debugging and try out the example inputs down there. And it says char is not defined. Oops, I meant char2. Now that should work. Yep, 10 out of 10.